Welcome back, everybody. So the contactor issue that I was having with the prototype has been resolved. What I figured out is down here on the contactor, which is the round gray thingy with all the wires connected to it, the low side, which is this side, it's safe for me to touch it because I disconnected the battery, but this low side here, which is supposed to have 12 volts, wasn't receiving power. So actually I had the wires hooked up wrong. They were backwards. And it's an easy mistake to make, especially because I was looking at actually the incorrect schematic for this contactor. I thought I was looking at this one, but it was for another one. So, those are just things that you need to watch out for when you're doing your projects. Just make sure that you're looking at the correct wiring for the item that you have in your hand. So this gets power now, and how this works is there's an electromechanical switch inside here, and when the key switch is turned on, a relay is closed in here, and so on the coils. And what that does is then it completes the circuit, and then you have power to the motorcycle. So my key switch is right here. I had to install it upside down because unfortunately this headlight bucket is too big to have it the other way. But anyway, it works. And the way you turn it on is it's actually the opposite of what I thought. So even though this says ACC and this is where it hooks up here and this is key switch on, this is off, but it's actually the opposite. So I marked it with a piece of chalk over here to indicate what is on. So when I turn the key switch on, you will hear the contactor switch close. Oh, because I don't have the battery hooked up. Whoops. You see, everybody makes mistakes. I don't have the battery hooked up. But if it was hooked up, this would come on and you would see the display reading 0 speed. It has a speedometer and it has a RPM, engine RPM. I'll show you that in a future video. What I wanted to do now is to just show you a couple of things actually with the multimeter. So when you're doing a project like this, you may run into some electrical issues like I did, and you might think, well, how in the world am I going to find out what happened? So you can easily diagnose most electrical issues on your vehicle with a multimeter like this one. And this is a really cheap one. I think it was like $10. And it's got these different indicators on it. One of the first things that I like to check when I was first wiring everything up and getting it ready to test is I put my multimeter on this setting. It looks like a diode or something, yeah, and it reads this because there's nothing on it. I'm not reading anything. So it has 2 probes that are plugged in right here, and the probes are the black and red. The black is the negative, the red is the positive. And what you're going to do is, if you're not sure if you're getting electrical flow through a wire. For example, I wasn't sure if I was getting power to my tail light because of the wiring. So what I did is I put a lead or a probe, the probe actually, on this connection, and then the purple wire here is going to be my delivery of power from the key switch to the tail light, which is right here. And I was getting continuity between these. I'll show you. Let me see if I can do this. If I can show you. Oh, I don't think I can. I don't think I can. Well, yes, I can. Yes, I can. Oh, yes, I can. There we go. And then I will put the lead, the other one, on this right here, and you saw that it changed, right? So there was a small number red there, and what happens is that this multimeter sends a little bit of current through this wire or through these probes, and so then the wire reads a resistance, and that's shown here on the meter. So that tells me that that connection is good. But I wasn't receiving any power to this tail light. So when the battery was hooked up, I'm not going to show you now because the battery is not hooked up, but what I was seeing was 0 volts to this tail light. I was not getting any power here. There should be 12 volts here, and there's not. So why is that? Why, if I have continuity between these wires, why is there no power here? Well, it turns out that these brake and tail lights and this headlight here, this headlamp, I don't know if you can't see it in the tail light, but you probably can't see it here either. Well, you kind of can. You kind of can. These bulbs are incandescent, and basically an incandescent bulb works by a tungsten filament that you can kind of see there, and it's broken. So what happened is when I first turned this bike on yesterday and I applied 12 volts to this headlamp, it blew out. And you might say, well, why did the bulb blow out? And I know that it did because I saw it. It turned on for just a second and then it turned off. The reason for that is because this bulb is probably not meant to receive 12 volts. A lot of bikes, like this one, I don't even know where this came from. I got this at the salvage yard, and it says, oh gosh, I don't know. I can't read it. DT 100 is what it says. So this probably came off of another dirt bike from somewhere. And dirt bikes generally have 6 volt setups for their headlights and their tail lights. And I have set this up for a 12 volt system. So what I need to do is go get 12 volt LEDs, and that should fix that problem. Another thing that you want to make sure of is that you use the correct fuses. So this is the fuse box that I made with inline fuses, and I did the inline fuses so that it would be easy for me to solder and then remove fuses as needed. And so you can see that I've put 20 amp fuses in here. Why did I put 20 amp? Because number one, the 10 amps were blowing. And number two, the gauge wire is bigger than what 10 amps fuses can handle. So this wire is meant, this gauge wire is 14, and they should run at least 15 amps or up to 15 amps through this wire. So that's not going to work for 10 amp fuses. So I went ahead and just put a 20 in there for good measure, but you don't want to put more than 20. Okay, like for example, I was looking in my toolbox and I had 40 amp fuses. You certainly don't want to do that. Why? Because if your wire is like this, is not meant to run 40 amps through it, okay, you will have a huge problem. At the very least, you will short circuit your system and possibly damage your electrical components. On the worst end, you could have an electrical fire. You don't want that. Why would you have an electrical fire, you say? Because the resistance will be so high in this little wire that it will get so hot, it may spontaneously combust. Trust me, you don't want to find that out, okay? So just make sure that you're using the correct fuse for the correct application. How did I know that a fuse was blown? That was the first thing that I checked yesterday. So what happened is that this light came on and it went out immediately. And I also noticed that the display had stopped working as well. However, I checked my contactor voltage right here, and I was still getting 12 volts. So that told me that I had a blown fuse, and I certainly did. So that's how you check these things. So that's a little bit of electrical motorcycle diagnosis and troubleshooting. And I know that it still looks like a mess, but it's really getting there. And I'm going to be doing initial testing of the turn signals and the horn today as well. I hope to show you videos a little later on that demonstrate the functionality of this motorcycle's capabilities. Then I'll be putting it on the test stand to actually run the throttle and get some RPMs going. All right, well, until that happens, I will just continue working, and I will see you guys next time on the Celtic Tiger Motors Garage. Thanks for watching.